Okay, let's try this again.
Okay.
Okay. It was kind of bizarre. My cursor stopped working. And I've tried writing with the mouse, and man, that is hard.
I'll bet.
It's like writing upside down left-handed. So that would not have worked. All right. If I draw just that part of the figure, then what is y equal to? These are parallel lines with a transversal.
Wouldn't it be 180 minus y?
Well, yeah, that's always the case, but it's equal to that angle right there.
Okay.
Right? In other words, when we draw transversals of parallel lines, we only create two angles, and all 8 angles are one of those 2 angles. Notice we create a small angle and a big angle. And these 8 angles are either A or B. They're either the small angle or the big angle. So when I look at this part of the picture, I can see that this angle is the big angle, so it has to be equal to this one up here. So what can I say for that in terms of an equation? Y equals what?
X plus 45
Now what
minus 180?
No, just that.
Just that? Okay.
Yeah, we know that these 2 angles add to 180. They're supplementary. But they haven't really asked us about this angle over here. So we don't really need that. Because all they want to know is what is the value of y minus x. Well, once we've written this equation, solve that, what is y minus x?
45.
Right.
Okay, that was a lot easier than it looked.
Yes. Okay. This is line M. This is line L. Excuse me.
Bless you. Bless you.
Thank you. You're having to say that every time we have a session here, huh? My allergies must be kicking in.
Oh, mine are big time.
Yeah, mine have been kicking in and out for the last couple of months. But sometimes I have to take something. Today I didn't take anything for them. Okay, if that line is L and this line is M, and they're saying this bisects the angle between L and M, no, excuse me, M bisects angle AOC, and L bisects angle AOB. So what is the measure of DOE?
Okay, and then once again with the 180 degrees would I'm thinking, let's see, DOE. Wouldn't DOE be 180? I don't know.
Well, let's just draw L and M. What is angle 1 plus angle 2?
180.
Now,
No?
no, that's correct. Actually, I did that wrong. Let's see. Let me draw the rest of them here. The measurement of these angles there is what?
Those would be 180.
Okay, it doesn't change if we draw this third line in.
That's still the same.
So what we know is that line L bisects AOB and line M bisects AOC. Well, you just told me that AOB plus AOC adds to 180.
Correct.
So this has to be supplementary to that.
So it's 90.
It's 90 is the answer. Because if I have here, if I want to set it up mathematically, I have angle AOB plus angle AOC equals 180, and L bisects AOB, so 1/2 of angle AOB plus 1/2 of angle AOC has to be 90.
Okay.
I multiply both sides. In other words, I can get equation 2 by dividing equation 1 by 2. All right. That one was a little tricky, but if you were guessing, you probably would have guessed 90 degrees. So,
Probably.
yeah, just estimating it. In other words, if all else fails, don't be afraid to look at it and look that that's awfully close to looking like 90 degrees. Now, that's a little dangerous because they do tend to draw figures not to scale. Although I don't know if they always label that. I'm not sure. Have we? I think we have. Yeah, we did see a problem yesterday, which was the bigger angle, and they had drawn B as the biggest angle when it was actually C. Remember that problem? Yeah.
Yep,
so
I do.
we can't really count on the figures they give us to be accurate. And if I remember correct, they did not label that not drawn to scale, or did they? Do you remember?
No, they didn't.
Right. Okay. Unlike the SAT test, which if it's not drawn to scale, they have to label it as such. If it's drawn to scale, they don't need to. So that matters. Okay. Here we have line L is parallel to K.
Would they be equal? They both be 50?
No, notice that we don't have the, in other words, X is equal to this angle right here.
Oh, okay.
It's not equal to that. That angle would be equal to this angle here.
Okay.
Okay. So algebraically, this is difficult to analyze, but graphically, it's quite easy to analyze. Imagine we have toothpicks laid over one another here to create this figure.
Okay.
Take this toothpick that I'm pointing out right now, pick it up, and rotate it left
Okay.
so that it maintains its vertice right there, but it makes angle X bigger, correct?
Yes.
Does it change the 50-degree angle at all?
No.
You see what I'm
I do.
trying to describe? It's sometimes hard to describe graphical solutions to stuff. But since you can do that, And I can basically make this angle bigger than 90 degrees. Well, not quite anything, but I can make it bigger than 90 if I slant it all the way like over to here. In other words, I can make it obtuse.
Right.
And if I slant it really far to the right, I can make it very small. So I can make it less than 50 or I can make it greater than 50. Since I can do that, I can't solve it.
Okay.
I'm sure that there's probably an algebraic solution to that, but I'm not sure what it is. And I like graphical solutions, although it kind of depends on the person. Some people are good with graphical type solutions, others are not. Okay. Here we have AB parallel to CD. So we got two transversals in operation here.
Okay, so B would be 75.
Okay.
So A, I don't know what A would be.
Well, you can't figure out A directly just knowing that B is 75 because there's still two missing angles.
Right.
So let's use the information that AB is parallel to CD to try to figure out another angle. Actually, when you encounter a problem like this and you can't figure out A directly, start figuring out everything that you can figure out. What's this angle here?
Let's 73.
Okay. So if this angle is 73, that line is parallel with this line. What angle over here is 73?
A.
Correct. What's angle C?
32.
Right, because that's equal to that because they're alternate exterior angles of the two parallel lines with a transversal.
Okay.
So B is 75. What do we figure out A was? 73?
73.
Okay, so B is
bigger.
Yeah.
So again, I'd say that A plus B plus C plus D would equal 180.
Now, where are you getting that from?
Because of the straight line.
Well, A plus B plus C is equal to 180. Okay. But not A plus B plus C plus D. We can say C plus A plus D is equal to 180.
Well, in all of them, 2A plus 2B plus C plus D would be 360.
Okay, what was that? 2A plus 2B plus C plus D equals 360. Okay.
So if that equals 360, then just A plus B plus C plus D would be smaller.
You can't infer that because, in other words, we can't compare this. Oh, I see what you're saying. Well, knowing that this is equal to 360 doesn't really tell us anything about a plus b plus c plus d compared to 2a plus 2b. This is a pretty tricky problem. Let's go back and take a different approach. I think that your approach would eventually get there. The problem is that there's going to be so many equations. In other words, I can write a bunch of equations here. I can also say a plus b plus d is 180, which gives me a fourth equation. But getting a handle on all of those equations is going to be difficult.
Okay.
And there's a better approach. If we look at what of these are equal, what can I say?
Well, 2a, they're both equal.
Well, a is equal to a because they're vertical angles.
C is equal to b, b is equal to d.
Okay, those are the keys. C is equal to b and b is equal to d. And wow, that makes C equal to D. This, I've read the solution in the book, and I'm fine with it. I'm just not sure how you go about starting with their first step. But what they do is they start off by subtracting an a plus b from both sides of this, I don't know what you call these. It's not right to call them equations. Relationship. The relationship between a, b, c, d, a plus b plus c plus d, and 2a plus 2b. So I can subtract a plus b from that relationship. And what that gives me is c plus d over there and a plus b over there. When I subtract an a plus b from the right side, I get a plus b.
Okay.
Okay. Now we know that c is equal to b, so I can subtract a c from both sides, and I get d compared to a. Now, if we look at the picture, which one is bigger? There's no way to determine whether A is less than, greater than, or equal to C.
Okay.
Or D. In other words, I could also, once I get to this step here, I can subtract, I can get A equal to D, or I can get, since D is C, I can get A equal to C also, since C is equal to D. So I also have this relationship, either one. Now, I'm looking at it graphically and trying to see, once I get down to this final step where I'm comparing C and A, can I figure out which one is bigger? Notice if I take this line right here
And move it.
and rotate it, I can make C bigger or I can make A bigger. And since they don't tell us anything about that,
It can't be determined.
right, nothing prevents me from moving that line. In other words, that line is not fixed at an angle since they haven't given me any angles. So I can definitely rotate that line, making C bigger in some cases or A bigger in some cases. That
Okay.
is a tricky problem.
Yeah, it is.
And like I said, I'm not quite sure how you figure out how to make that first leap, which is whinnying this down. In other words, start subtracting from that side and that side to get it down to A and C. Let's see. I can read it from this page. Similar question?
Yeah, I was just going to say, once again, it looks like you can probably move the lines and make any of the angles bigger or smaller.
Well, A plus B plus C plus D is this set here.
Right.
And it's true that if I rotate the line on the left, I make some of those bigger and some of them smaller, but I don't change the sum of them.
Right.
What is the sum of A plus B plus C plus D?
I was going to say 360.
Yeah, because these two are supplementary and these two are supplementary.
Okay.
So they have to be 360. Well, what's the sum of E plus F plus H plus G?
Also 360.
And no matter how much you rotate either of these lines, that's
It's still
always
gonna
going to
be-
be true. It's always going to
Got
be 360 equals 360. That was quite a bit simpler than the previous one. One of my more favorite problems. Whenever I'm tutoring a high school student for the SAT, I inevitably give them this problem because there's a shortcut with this problem. As opposed to doing it the hard way. Now, I don't know if that shortcut is going to be that useful to you, but it actually might be. Is particularly in this problem. The secret to solving the problem is to extend one of these lines. Okay, let me label all my angles. What's this angle right here?
What's going to be equal to Z?
Actually, look at it. We have parallel lines. Whenever you're given a problem with parallel lines, instantly try to remember parallel lines and transversals. This is X, right?
Okay.
Because we have two parallel lines, and this is the transversal.
Okay.
So that's X. What's this angle here?
Z?
Well, it's not Z. It's supplementary to Z. So it's equal to 180 minus Z. Let's call that angle 1. Angle 1 is equal to 180 minus Z, right?
Uh-huh.
Well, relative to this triangle that I've drawn, what else is angle 1 equal to?
It's equal to... I was going to say X plus Y.
Well, 180 minus X plus Y. right?
Uh-huh.
Three angles have to add to 180. So x plus y plus angle 1 equals 180. So angle 1 equals 180 minus x plus y. Well, since angle 1 equals this and angle 1 equals this, we set those equal to each other. I can cancel that. I can cancel that. I can divide both sides by -1, and I get z equals x plus y.
Okay.
Okay. Now, the shortcut that I show everybody to avoid the minute and a half of math is that when you are looking at a M, this angle 1 is always equal to angles 2 plus angle 3.
Oh, okay.
And to view this as an M, merely tilt it 90 degrees to the left.
Okay.
But it also works in problems like this. Same problem, different direction M. This angle 1 equals the sum of the two corner angles in the M.
Okay.
And that's definitely a useful little shortcut when you encounter problems like this.
It definitely is, yes.
Yeah. Although it's worth knowing how to do it the other way also. In other words, parallel lines with transversals comes up so frequently in these tests that you definitely want to be really good with parallel lines and transversals. And the thing is, it's not that hard to be good because you really only have two angles. And those two angles are supplementary to one another. Always remember that. If I don't care which is the bigger one, they add to 180. And every other angle is one of those two angles. It's either the small one or the big one. Or they're all 90. In which case this transversal would be perpendicular to the parallel lines. All right. I think that is the end. Yeah, it's the end of that section. Let's go to triangles. My son's trying to talk me into getting the new Samsung Galaxy S4. And one of the advantages is it has a 13 megapixel camera on it.
Oh, wow.
Really would outdo I have a 5 megapixel camera on mine. That's what all of these were taken with a 5 megapixel.
Yeah, 13 would really be nice.
Yeah, it would be. It would eliminate, I'm sure, all the blurriness that I end up with here. Although, for the most part, I'm generally using pictures that students are sending to me with their cameras. Although occasionally I'll scan a bunch of problems into my computer like I did this time. Okay, what's the value of x in the triangle above?
I would take 30 plus 2x plus x equals 180.
Okay.
And then solve for x.
Okay. So we got 3x equals 150, x equals 50. Notice this could also be done back solving fairly easy.
Oh, it could.
Yeah, if I start with 60, that would be 60. That would have to be 120. That's not right. And then if I try 50 and 100 and 30, 180, bingo, I'm done. But no faster than the algebraic. if the difference between the measures of the two smaller angles of a right triangle is 8 degrees, what is the measure in degrees of the smallest angle?
Okay, well, I know that let me see, if the difference between the measures of the two smaller angles is 8 degrees. Well, I know that together they have to equal 90 degrees.
Okay.
I'm sorry, my dog is barking her head off.
No problem. I can still hear you.
Uh-oh.
And my dog has joined the fray. I never thought about that. Good thing I don't have a meeting with 10 participants in it and everybody has a dog. Otherwise, we'd have a kennel.
Yeah. Okay, so I know that they both have to equal 90 degrees.
Now, I can see you're kind of struggling with the algebraic solution.
I am.
So what I'd like you to do is think the back-solving solution sooner than you do. In other words, the back-solving solution here is really very easy, whereas the algebraic solution is a lot harder. If we're going to back-solve, which one are we going to start with?
I would start with D.
Notice that it says, what is the measurement of the smallest angle? We want to start with
37 or 41.
Well, we could.
37 or 40.
I'm sitting there thinking it's actually more efficient to start with 41 here.
Okay.
Because if 41 doesn't work and we know it has to be smaller, we'll know the answer. Right?
Yes.
In other words, we could start with 37 as the smallest. We could let this one be 37. That makes this one 53. Do they subtract to 8? No. So I know it has to be bigger. So when I try 41, that makes this one 49. Now they subtract to 8 and I'm done.
Okay.
So the back-solving method is lickety-split on this thing. And it frequently is. It really, you almost have to train yourself to look for the back-solving method first.
Okay.
Okay? Rather than the algebraic method. In other words, I don't blame you for doing this algebraically. I probably would have done this one algebraically also. But notice how fast the back-solving method actually worked. We didn't really need to do it algebraically. This one, the back-solving method is much faster than the algebraic method.
It was, yes.
In other words, the algebraic method is y minus x equals 8 and y plus x equals 90. So there's two equations, two unknowns. We can solve for one of the angles and get the solution that way. This is interesting in the fact that I've said that if the question says what's the smallest or what's the biggest, you start with the biggest or the smallest. But I'm beginning to re-examine that. In this particular problem, it makes more sense to examine the second smallest first, because you're immediately going to know which direction to go. So this actually fits the standard back-solving model. Well, you would always start with B here. You would never start with D.
Okay.
You don't start with the bigger numbers because they're going to be wrong and they tell you they need to be smaller, but that doesn't narrow it down.
Right. There's still 3 below that one.
Right, right. So we're going to start with B here, but really for a different reason than we start typically with either B or D. Now, you may have memorized the area of an equilateral triangle. I'll bet you have.
I did. It is side squared, square root of 3 over 4.
I even memorized it, which is more amazing, because I had never memorized it before. Unfortunately, that doesn't help here because they give us the altitude.
Right.
If we knew the side, we'd have the area instantly because the area is 1/2 base times height. So if we knew the side length, it'd be no problem. So this formula doesn't really do us any good here. So what we need to measure is that dimension right there. Because we know that that's half of the side. So if we can figure out this dimension, we'll be able to figure out the entire base. Now we got base times height, piece of cake, half times base times height. So how can I figure out x? We know that an altitude always makes a right angle with the base.
Correct.
And in an equilateral triangle's case, it bisects the base.
So wouldn't it be 3?
No, that would mean the base would be 6. And that actually couldn't be because the base is the same on all 3 sides of the triangle.
Okay.
And that means that that's also the base, and the base has to be the longest side of this right triangle, so the base has to be higher than this altitude. So the base is going to be greater than 6, which means x is going to be greater than 3. But more importantly, what do we know about equilateral triangles in terms of angles?
Well, the smaller angle is usually equal to 1.
What's this angle right here? If this is an equilateral triangle, what are all the angles equal to?
60 degrees.
What's this little angle up here?
30.
Always remember, they're always going to give you triangles in 30, 60, 90 or 45, 45, 90.
Okay.
So when you see triangles, look for that. Okay, now we have a similar triangle situation. What's the dimensions of my unit similar 30, 60, 90 triangle?
It's 1 square root of 3 and 2.
Okay, so let's solve for x based on that.
Okay, x would be 3 square root of 3.
Okay, let's see.
Oh, wait, no, because... Oh, no, that would be right. Wouldn't, no, it'd be
Let's
6
set up, the way I taught you to do these is to find the comparable sides.
Right.
That side is opposite the 60. This side is opposite the 60. Divide them to come up with the scalar ratio factor, the linear ratio factor.
So it's going to be 6 divided by square root of 3.
Correct. And then we're going to take that factor and multiply it by whatever side we're trying to figure out. If we were trying to figure out this side here, which actually we are, I mean, we're most directly going to figure out x, but once we figure out x, we'll have the base. So really, this is what I'm trying to figure out. I mean, I don't need to go there. We can figure out x. So I multiply it by 1.
Okay.
To come up with x. So x is equal to 6 over root 3. Notice that if I multiply it by 2, I come up with the hypotenuse. So the hypotenuse would be 12 over root 3. Well, since the area of my triangle is 1/2 base times height, I know it's 1/2. That's my base, or twice that is my base, either way. Times the height, and all of that becomes 36 over root 3, which you're never going to see that answer on a test because we have an irrational denominator. Have we gone over rationalizing the denominator?
Yes.
Okay. So what's this equal to? Which answer is that equal to?
It's going to be 12 root 3.
Correct. Okay. Two sides of a right triangle are 12 and 13. Which of the following could be the length of the third side? Indicate all possible lengths. And we could draw a picture of this, but almost more confusing if you do. Let's try it anyway. There's 12, there's 13. So what could this be? Could it be 2?
Yes.
Okay. Could it be 5?
Yes.
Could it be square root of 31?
Yes.
Could it be 11?
Yes.
Could it be square root of 313?
My guess would be no.
Well, let's see. What is that number?
I was going to say that 313.
It's not that big. 20 squared is 400. So that's some number less than 20 squared, even if it's 19 and change.
So yes, it can.
Yeah, it can. But the rule for triangles is what?
That the third side has to be bigger than the difference, but smaller than the sum.
Correct. And it's any side, not just the third side. Any side of a triangle, no matter what triangle you pick, any side has to be smaller than the difference, greater than the difference, or less than the sum.
Okay.
Oops, what did I do that for? I meant to do this. Let's see. Yeah, I want the value of PS. It's all right. My dog, I never knew how many animals there were on TV commercials until my current dog, because she chases the TV every time one comes on.
Okay, that's cute.
And it's about 90% of commercials. I'd say 90% of commercials use an animal. It's somewhere in them. And not only does my dog chase them, but my dog's got them all memorized. If she's outside on the patio and my TV is on, the first note of a commercial that she recognizes is going to have a doggy in it, she comes charging in.
That's funny.
To watch it. Yeah. I've had a lot of dogs in my life. I've never had one that interacted with TV until now.
No, I know. I haven't heard of that before. That's actually extremely smart.
Well, a friend of mine told me that before high-def TV, dogs couldn't read the signal as well. And now with high-def TV, they see what's going on. So I don't know if that's the explanation or not, but it is pretty funny. It is pretty funny. She gets plenty of exercise just running from my couch to the TV and back 100 times a day. All right, so we have a triangle here. Usually when they ask about triangles, the goal is to just start filling in the missing pieces that you don't know.
Okay.
They've given us QR, 16, and PR, 20. Can we figure out PQ?
I'm going to say, let's see, 12.
Okay. Use a 3, 4, 5 triangle?
Yes.
Okay. And now what is PS?
13.
Good. You use the 5, 12, 13 triangle.
Yes.
Okay. So D.
I have been trying so hard to memorize everything.
Right, but you can see how much time it saved.
Yes.
Because without that, we would have had to been doing the Pythagorean theorem to come up with 12, and then the Pythagorean theorem again to come up with 13. Right. So there was a tremendous savings on that, knowing the 3, 4, 5 and the 5, 12, 13. Okay, number 6. We'll go extra 5 minutes. Is that about how much time I missed?
You know what, and you don't even need to do that. I mean, that's fine if you want to stop now.
No, I'm fine.
Okay.
We can go further. Yeah, I don't have much going on today. If you do, on the other hand, I'm happy to stop also, but...
No, I don't really.
All right.
I'm just glad my dog stopped barking.
I go through that all. Imagine how often I go through that, because my dog
I know, a lot.
barks a lot. Yeah. That's much more embarrassing on my end, since I'm the tutor. I'm supposed to control my environment a little better than that. But.
Okay, so if the measures of the angles of triangle are 1 to 2 to 3, and of course my first inclination would be say 30 because it's 3 times.
Okay, notice what's going on here. They're talking about the angles, and then they're asking about the lengths.
Okay.
Okay.
Angles are in the ratio of 1 to 2 to 3.
Right, and it's not that easy without invoking trigonometry to come up with lengths based on angles, unless we get lucky and it's a right triangle. So in this case, we're going to need to figure out what these angles are.
Okay.
So how do I do that?
Of course, my first inclination, once again, it's 30, 60, 90.
Well, that's a good inclination. In other words, you pick some numbers and see, does that work? Yes, it does. There's the 1, there's the 2 times the 1, and there's the 3 times the 1. So we have a 30, 60, 90 triangle. And they said the smallest side is 10. The smallest side's always opposite the smallest angle. So what's the largest side?
It's going to be 20.
Bingo. Okay, let's do 7. That would have actually been a near impossible problem to solve if it did not come out to be a right triangle. In other words, if that was anything but a right triangle, we would have no method of solving it. I suppose if it's equilateral maybe, or isosceles possibly, but it can't be either of those.
Right, because of the ratio of angles.
So you can almost, if you understand that principle, you know that this has to end up being a right triangle, otherwise we wouldn't be able to solve it. Okay, this one here.
Now, I'm not sure if I'm remembering this correctly, but when you have a figure like this one, the x, isn't that equal to the two furthest angles inside the triangle?
Correct, but unfortunately that doesn't help us here.
No, it doesn't, but I was just wondering if that was correct.
That's a good thing to remember. X is equal to 1 plus 2.
Okay.
It's the alternate, or the exterior angle theorem. And there's actually something else going on in this that you need to recognize. And it's harder to recognize because of the way they've drawn it. If I drew it like this, what is angle 1 and what is angle 2?
Um, 65 and 65?
Correct. In other words, is all I did was I rotated it so that it was more recognizable as an isosceles triangle.
Yeah.
The fact that they have it laying on its side makes it tougher to see. But if that's 50 and that's 50, it's isosceles, which means that angle is equal to that angle. We can solve, they're each 65. If that's 65, that's 115.
Okay.
Okay. Solving these problems is always a question about trying to solve for as many of the blank spots as you can. Well, not really as many, but the most efficient method. You don't always have to solve for all the blank spots, but in this case you kind of do.
Okay.
Let's do one more here if you want. Want to give yourself a headache right before the end of the session? Let's do this. Just not because it's hard, but because it's blurry. In the figure above, what is the measurement of angle W? We have no information. None of these are parallel. This is just another geometry problem where you have to fill in as much information as you know and go from there.
Okay, we know that that's a right triangle.
Okay. So what's this angle?
30?
40. In other words, the two angles in a right triangle that are acute always are complementary. They always add to 90.
Yeah, that was stupid on my part.
That's a good thing to memorize all on its own. It's like saying that the two angles that form a straight line, these are always supplementary. Well, in a right triangle, x and y are always complementary. And you can always get there by saying the three of them add to 180, subtract 90 from both sides, so you always end up with x plus y equals 90. But that's a good thing to memorize all on its own. So if that's 40, what's that?
That's also 40.
And if that's 40, what's that?
110.
Correct. And that's a good problem, pretty much a standard way to solve most of their geometry problems. Just start solving for the stuff you don't know.
Okay.
Okay, so we got through 8, and we'll pick up with 9 on Wednesday.
Okay, sounds good.
All right, Angela, talk to you Wednesday.
Okay, thanks.
Oh, yeah, no, that's fine. I'll only process the second file, the first file where you didn't have anything on it. So
Okay.
the file I put up will start at the beginning.
Okay, thank you.
All right, bye-bye.